Hello, good evening.
Good evening. Good evening.
How are you?
Yeah, good.
Okay. Karthik Kishore.
Yeah. Tell me about.
Yeah. You are coming first time?
Yeah, this is first time in the group discussion. Yes.
Okay. So, can you please introduce yourself?
Okay. Myself, Karthik.
Yeah. So, total how many years of experience?
Myself, total sound plus 5, 7.5.
Seven, means around 7 or
Yeah.
8 around. Okay. So, Mr. Kaushik Biswas, uh, can
Yes, yes.
you are also coming first time?
No. I'm maybe after 2-3 months. I'm joining again.
Okay. Means 2-3 months you came and after that you are joining. Any specific reason that you're not attended in this?
No, I was busy with my work.
Okay. Uh, there are some few new joiners. Can you please introduce them yourself?
Okay, I'm Kaushik Biswas. I'm a founder of Equicad solution. So we are dealing with automation of heat exchangers and pressure vessels. I have more than 15 years of experience in this field. I worked in different countries. Currently, I am in Malaysia. I think that's enough from my side.
Yeah. Normally, Kaushik, his automated equipment means whatever our vessels is make that one by using some software. He makes automatic modeling of that equipments. So easy to fabrication drawings, easy to 3D models like that he will use to do. Right, Kaushik?
We are doing that. If anybody interested, they can view now. It is the 3D models are live in my website. You can go to the showcase. You will find the 3D models there.
Yeah. Thank you, Kaushik. Maybe you can just put your website in the chat box.
Yeah,
Yes.
link you can share. So they will all used to see. Uh, okay, Karthik, do you have any issues, anything you want to discuss?
Yeah. Just I would like to know what this UG-44B requirement is there for the nozzle flanges.
Oh,
Are you aware about that D-rate check for the nozzle?
yeah. What do you want to know
No,
regarding
that's
that?
in my case. My case I'm facing some issues. When it comes to 150 rating, it's getting failed in UG-44B. What will be the solution for that? One
Yeah,
thing
you
we
need
need is
you need
the
to.
nozzle rating, or else we can do for appendix 2 for those nozzles.
No, you need to increase the. One option is you can try to reduce the nozzle loads. Otherwise, you need to increase the flange rating. No other option.
We can do appendix 2 for that plant, right? Is there any section in the code?
No, but if you do also, what help you get? You don't get any help because even
No,
appendix 2 is worse.
no. If I got passed in appendix 2 means it's okay, right? Because I could see for 8 inch, more than 6 inch and 8 inch, it will get passed in appendix 2. For the below sizes, I agreed it will fail in appendix 2.
Uh-huh.
So no, just I'm asking. It's okay to go with appendix 2.
Yeah,
Only the thing we need to the rating.
yeah, you can do. Yeah, that is okay. That is allowed. But are you sure the flag is passing in appendix 2?
Yeah. It's possible.
Yeah. Let's just check whether in PVElite whether you have maybe by chance you click that standard flange
No.
rating.
I'll use the dimensions as per B16.5 only.
No, but that there will be one tick mark, no? That use the rating.
Yeah. Of course, we are doing appendix 2 means we have to remove the tick mark. Yeah. Definitely, I will remove the tick mark. After that only it will calculate the thickness calculation.
Yes. So if it is passing in appendix 2, yes, it is okay.
It's allowed to use, right?
Yes, it is allowed to use. No problem.
Okay. That's what I'm right now. I need to convince my client. So that's the thing. We are I want to discuss that. Just you guys are more experienced guys, so you might face a lot of problems while you are executing a project.
And in that you are entering the loads and all.
Yes. Actual force and the moment I will enter in that phase of line.
So how do you put the movement? How do you put the movement?
Load for the nostrils. That is the option, right? In appendix 2, we can.
No. I am saying how you will put the movement, particularly movement. I am asking.
Movement. You will enter the movement. What for that nostril?
No, that what movement you will add? Just to help you with.
Okay.
Under root ML square plus MC square.
Yeah, that you need to put that. Hope you are doing that.
No, I didn't get you. Come again, please.
See, in the nozzle loads, you have various load, right? Axial load.
Right.
And so axial load you will put. That is one. For the movement, there will be ML, MC, and MT.
Yeah.
So while you are entering the movement, you need to calculate the square root of ML plus MC.
Okay,
square.
You need to say resultant movement have to enter?
Yeah, you need to put whether you are putting that or not. Just
no. I am not putting resultant movement.
That's now you check.
Wait, sir, anything because we used to put the resultant in the shape of the descent like that we used to put, right?
No, not that. See, if a standard flange, you see the PVElite how it is calculating. You just compare. You will know.
Okay.
So the correct way is to that you need to. You just put MC or ML. That is not correct.
Okay.
Basically, you need to put ML square plus MC square square root over that. Now with that you put whether it is passing because I have my own doubts because generally appendix 2 is worst compared to the normal rate.
Okay.
But still it is passing. Yes, it's okay.
Okay, sir. I will check with by putting resultant.
And make sure the double check whether you are giving the correct gasket dimensions and
Right. Yeah.
double check it.
Yeah.
Because based on the gasket dimensions that will change.
Okay. Oh yeah, definitely.
Yeah.
TF will might change it.
Yes.
Okay.
Karthik, can you tell me what actually your issue is?
My issue is my equipment is having the pressure of 12 bar, 50 rating. While doing direct check for UG-44, it's getting failed for nozzles, all nozzles.
Okay.
So what my client is saying, it need to be not a client. Our code says it need to be check with UG-44. But in my former, we used to do appendix 2, and we can submit the calculation as annexer of the main calculation.
Okay.
So now this right now I am working in this company. They are not allowing me to do that. That's what I need some backup to do. So an explanation. This is not. This also allowed us for the code. We can go with this way also like that. That's why. That's my theory.
No, appendix 2, as per my knowledge, it's you are calculating the flange one, and the UG-44 you are calculating for derating one. So So
both thing that we are applying the loads on the face of flange, and we are saying that it's satisfied for that load. That's the thing.
Yeah, but this when you appendix to when you are using, you are applying directly loads on that one. But UG-44, you are also derating that flange. Means the life of that flange and that one, it also take care in that one. That's why I think it's failing. Means if
No. In appendix 2 flange calculation also there is there is an option in that to put the load, axial load and moment. There is an option.
axial load and
Yeah.
moments are there, but whether it's taking care of this derating of flanges.
No, it won't.
Yes.
Actually,
Yeah, it takes care.
it only takes for the hydrostatic pressure. It won't derate it for the actual condition. Only it will check only for the hydrostatic test.
Yeah, as per my knowledge also it's only checks
No,
that
no,
one.
no,
No.
I applied the MAWP value as a design pressure only.
No, actually, the same issue I have had to face recently. So PVElite will give a slight warning. Even that warning is in the blue color also, not in the orange color.
Yeah, red color.
Anshul, that hydrostatic pressure, that is the terminology from the code. It doesn't mean it is, hydrotest pressure.
Yeah, no, actually the thing is, I'll tell you the background of it.
Yes.
The client wanted to have the vessel not governed by the flange MAWP.
Right.
And all the nozzles were to be checked for the derating, and even after derating, their MAWP should be higher than the other parts of the vessel. They should not be the governing MAWP.
Okay.
So, for rest of all of the nozzles were having high. We required to provided one size higher. So client was not happy with that because even though it was his spec, he wanted to go around the way. So we tried that method also. What we did, हमने nozzle में से we removed the standard flange and we added the design flange there. And we took the axial load and the resultant moment and added in the moment and torque section that we have there and ran the calculation. And even the client accepted that. But after 1 or 2 weeks, when I was just going through the calculation of that and the UG-44, I saw some difference that in that calculation, they don't take the formula of the DNV and PVP formula there is, no? That is not considered. They are not adding that in the calculation, and after, I don't know, there is one criteria of checking MAWP and minusing something. I don't remember the exact formula, but that particular thing is not happening there. So that is why.
Yeah, right. But that you can do manually, no problem.
Yes.
Actually,
Yes.
there is a in UG-44B they will consider something called movement factor.
Yes,
So,
yes.
that you can do manually. What you can do, you can do the I mean, if you are still concerned about it, what you can do, you perform your calculation as per appendix 2. So whatever the MAWP you get from that output, so in that you make that equation as per UG-44B, that you can you can make a simple Excel. It doesn't take much time. So
Yes,
still you can do that.
Yes, I checked with that calculation, but the result was almost identical to the standard plunge. So we decided to just go with the standard plunge with higher rating.
Yeah, that is what I'm saying. That is what I'm telling Karthi. Generally, appendix 2 is generally worse compared to standard plunge. But anyway, Karthi, you can just check this approach.
Yeah. So, sir, I will check that. As you said, resultant moment we need to apply on the nozzles, right? I
Yeah.
will check
Also, you see. I mean, when you enter the, I don't know whether the PVElite has there is an equation given in the UG-44B. That equivalent pressure calculation, they have given an equation. So that equation is generally different from what industry, piping standard uses. So this, I believe, this appendix 2 uses that, what is called leakage check, something Kellogg equation, something they'll use it. Just compare, just compare, whether it is calculating as per UG-44B or not. If not, you can make a simple Excel, and you can just make one check with that.
Checklist again.
Yeah, this Excel also you have to first check
Okay,
like
why
whether.
I'm asking? In my case, that 150 rating need to be increased up to 600 rating.
Yes.
Is that required to increase up to 600 rating?
The flange must
Yes.
be 2 to 6 inch, right?
Yeah.
See, that,
Flange
that
size.
2 inches, 2 inches,
Yeah.
and as well as 3 inches.
Yeah. So you have to increase
Not
that.
2 inches,
Yeah.
3 inches, pin size.
Yes.
No, but you ask the piping guy whether he can reduce the load.
Yeah, that is the only option.
Okay.
If the flange is up to 6 inch, generally 600 does come up.
I mean, it depends on the
Yeah,
load.
yeah.
Yeah.
So means 150 rating flange, if you do with UG-44, then it going to 600 rating flange, right, Karthi?
Yes.
Yes. In my case
general-
also like that one.
Okay, so it's too high. So better, as Ramakrishna told, that just ask your piping guy to reduce the loading on these flanges. So maybe your load will reduce. And this using Excel and that one also, maybe you have to get approval, because whether this client again he requires some validation of Excel, and that better use PVElite only, because that validation is not required in those cases.
So that is allowed. No doubt about that. But only the convincing the client part you take care. But it is absolutely
Yeah, they can't question us.
Yeah.
They can't question us if we follow the code, right?
Yeah.
Yes. The client generally doesn't.
That is code. As per code, the formulas are there.
Yeah, but please make sure what you're doing is right. So that
I've also
Absolutely, yes.
shared the link of all the DNV 50% pressure and the PVP calculation in the group. So you can also check that.
What did you share?
Actually, in PVElite UG-44 calculation, there are 3 methods that are being followed: PVP, 50% stress, and DNV method.
Mm-hmm.
So I've sent the procedure and the calculation that are being used in that. So a link I have shared for that.
Okay, you shared in the group.
Yes.
Okay. Are you sharing?
this option is talking about in where it is in the nozzle dialog box.
Yeah. If you go on the nozzle duration, nozzle MAWP,
Okay.
you will find the table with UG-44, and there will be 3 options. Generally, nowadays UG-44 will be PVP. There will be a statement written that PVP is just UG-44 calculation. Then the next column will be 50% stress, and the next would be DNV. And the worst of all 3 is being considered as the MAWP.
Okay. And
You
if you say
Yes.
none, it will not consider.
What?
If there is a none option also there. There is.
Yes, if you don't want to calculate the as per UG-44, because UG-44 is not a mandatory code requirement as of right now. It's just AI will ask for it 100% if you have external forces.
No, but but logically, if you see, that
Yes, logically also.
logically, if you see, that is to be taken care.
Yes.
The code may said that it may be required, but
Yes,
now it is mandatory. I mean,
It's a good engineering practice
Yes.
as of now.
and I say it is mandatory. I mean, because 99% of people will ask for it and doing it.
Yes.
Now code also saying, no, it's this U stamp vessels mandatory we have to do this UG-44 and that one calculation.
No, code right now says is as maybe.
In 2023?
Yes, 2023 also they have written as maybe, but AI will not accept it because
No,
the inspector
actually,
won't accept it. Even client won't accept it.
no. Actually, we need to see what is the language of the ASME. What does mean by maybe? That we need to interpret.
Yes.
For the language, here shall means what, should be means what, maybe means what. So
Yes.
that I think that you need to read the code. So then, based on that, you need to interpret.
Okay.
But I know the
Yeah.
PCC-1 is also a requirement, the mandatory requirement. No.
No, I think.
Yes.
PCC is not mandatory requirement. It's
Yeah,
again.
but as per code, our AI was just he was asking mandatorily for us to provide the PCC for each and every single flange that is the standard flange in our calculation.
So actually, it's required for tightening on the who is doing the
Yeah.
tightening activity. No? For him, he required that value to use that one within that limit and that one. So, but I think now the AI is making more things to be included in their calculations and that one, their documents.
Yes.
Okay, can we move next? Okay, Anshul, do you have anything, any points, any issues you want to discuss?
No. Lastly, I had the issue, but I think Ramakrishna sir might be right on that saddle thing. Last time I sent an inquiry regarding the saddle supported vessel that was being inclined.
Yeah.
Yeah, I wasn't able to capture a photo this week. I was very busy, but yes, my CG was very near to the left-hand saddle, so
Yeah.
that might be one of the concern issue.
Yeah. So
But
how they solved it?
As of now, the client has not commented back. We have provided him the calculation for about 1.5 weeks, but he has not responded on that.
Maybe I mean it's a problem during the maintenance if they want to remove, no, so then it will fall down. As soon as you open the bolts, it will fall down. Maybe you can add a counterweight on the other side.
Yes.
Counterweight or some supporting if you
Yeah.
add that also I think better.
Yeah, whatever. Yeah. So that is also like a counterweight only.
Yeah. Okay.
So you need to add some mass.
Okay.
Yeah.
Mass adding
Yeah.
directly on vessel is just you add some some structural
Yeah,
supports
exactly.
you can say at
Yeah.
the bottom side.
The thing was, QOC was the first of a kind job for the company, so none of the people thought about that if the QOC were to be open in an empty condition when it was open, one third of the weight will be shifted to a direction that was not considered in the calculation, even
Yeah,
in the second.
because generally QOC is massive compared to
Yes, the rest of the vessel. Yeah.
rest of the
Yes,
vessel, especially when the length is short.
yes.
This is a filter. What
Yes,
kind
filter
of
vessel. Filter vessel.
Yeah.
Okay, so your issue is just CG is shifted, so you want to make some additional support to that one to hold that
Yeah.
shifted
Yes.
CG.
Actually, the client concern was that during the operation, not the operation, when they take out
Maintenance.
the QC, even in the maintenance, when they open the QOC,
Uh-huh.
the bolt should not uplift. The bolt should not fail on that uplift position. But
He's
our
concerned. He's concerned about the bolt, but
Yes.
As soon as you open, it will fail.
No,
It will fall. Yeah.
No, one more option is
they
there.
don't-
Instead of this attaching this the hangers to the vessel, just you have to hold with this arm type lifting arrangement. So that holds this your QOC. You open and when this arm type lifting, it's pulls out, and it's no load will be transferred to that vessel. That's also one more option. We used to in some our maintenance of this pick traps and that one, we used to do like that, because if loads comes in one side, then this rather than we are holding that the opener, the hinge,
other side.
yeah,
Yes.
that hinge will be removed and it's directly connected to the crane type one arrangement. So its crane will be kept holded that opener, and then
Yes.
it will be pulled out. So it's not, no load will be transferred to that vessel.
Okay.
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 Any other? Anshul?
No, not right now. Anyone else?
Karthi, you have any more?
No, That's it from my side.
Okay, I think Atul Sharma Ramakrishna. Atul, you have, because you didn't started today.
No, I don't have any.
Oh, you didn't have. Means you are in holiday, I think. So you didn't get any queries.
Yeah, I'm on holiday and 2 plus days more.
Okay.
It's totally 15 days leave.
Uh-huh. Okay, Ramakrishna,
Yeah.
you.
Actually, somebody can tell their experience about Inconel material. Any, I mean, generally where it is used and what is the composition. Somebody can tell what is Inconel.
I only seen in Bello.
Sorry,
In Bellows only.
Bellows only. Yes. Acha, not on the. I mean,
I
Anshul,
I
can
have
you?
used 8020 on vessel and 8810 on pipe.
okay. So I mean, generally where this is used for high temperature or where generally this Inconel.
Yes, this 8020 vessel was for the filter vessel. So
Highly corrosive environment. Sorry, highly corrosive environment. There it is.
yes, sulfuric acid was the fluid.
Oh, okay.
Onshore projects.
Yes. So in my case, sulfuric acid was the fluid. So that is why they had the requirement of Inconel. And for double pipe heat exchanger, the temperature was 800 degrees Celsius.
Yeah, so it is a high corrosive and high temperature,
Yes.
right? Okay. So up to what temperature we can use this material?
It's, I guess, 825 to 850 is the limit that allowable is present in the code. But after 500 and something, the creep range starts.
Okay.
So below 500, you want to say that below 500 it's better to use.
Yes.
So Kaushik, did you use
Yeah,
any?
but by the way, what is this creep range and what is the concern?
The creep range is, how to explain it?
Material behave like elasticity.
Yes. Yeah. Over the high temperature during the service, the material will start to lose its property
Okay.
in a certain way. And it will crack it will, most probably crack at much lower stress than it should be. Because repetitive load will be there.
So I mean, so that creep range, whether it is given in the code.
Yes, it is given. See, if you see when you go through the value of the allowable stress, there will always be a sudden drop. Like the allowable stress will go from 138, 136, 132, 130,
Correct.
then suddenly 10 to 20 megapascal drop will be there in that range. That is about the creep range you will have. That will be the temperature where the creep will be starting.
So then, it is concern for each and every, so generally any.
Each and every material, yes.
But there is no concern, I mean, anything specifically about the code, I mean, in the code.
The code has reduced the allowable stress. That is as far as they have done. They have also provided that the allowable stress is based on the rupture in 100,000 cycle. So about 11 to 13 years cycle they have given for creep range. So creep material should not be used for more than 11 to 13 years. They should not be used without reassessment.
So I mean, you mean wherever for the SF-6 grade 70. So I think this allowable stress drop starts around maybe 160 degrees centigrade, something like that.
Yeah, for 516.
Yeah, I think maybe 160, 150, something like that. I think there.
516 is also good for high temperature. Its creep is also at 480 something for 500.
No, you're saying wherever there's a drop, no? You mean?
Sudden drop, yes.
Means after 500 it will be get dropped, or before that one?
Because
Like 516 grade 70, if you consider, you are saying that 480 or 500 degrees Celsius.
Or wait, I mean, let us open the part 2D and then we.
Yes, I'm opening the code.
Yeah, I can open. No problem.
Yes, one more distinction. You will find italic.
You can
the
share
creep
the
values in
screen,
italic.
so it will be.
Can you share or?
Just a minute. Is it visible?
Yeah, yes.
So it will come out about 11.4 years.
Okay. So this is duration. It is not about cycles. Okay.
Yes, for 11 years, it should be okay. Yes, 70, 45 plan.
Yeah.
So you will see 138, 138, 138, 138, 136, 132, 123, 123. Then after 123, 101 and 83.
Yes.
Yes. So the creep range has started at about 400 degrees Celsius per.
So, acha, wherever where they put it that in at Alexa, can you zoom in? I mean, we can't
Yes,
see
yes.
clearly. Okay. Okay.
Yes, and also in the
Yeah.
yes. As you will see, for high temperature where creep starts, they provided the values in this range 100% in 1 lakh hour. 100% of the stress will cause rupture at the end of 1 lakh hour.
Okay.
So on that basis, you can have the cycle or life cycle of that.
No, but if
But you have to assess if the fatigue is required, then you have to do the fatigue analysis.
no, that is okay. But generally, most of the vessels, they'll operate continuously. Maybe they will be shut down maybe once in a year, like that. Maybe 25 times. Is such a low fatigue means this not a concern.
Not required.
Okay.
Even in my case, at the higher temperature in color, the fatigue was not required to do operations. Yes.
So, this is whenever, if the condition is in creep range, we need to check for the number of cycles. Right?
Yes.
Okay. Generally 1 lakh, what is that? Hour? They given hour or what is it?
Yes.
Number of
RR.
Oh, okay. That is life.
Life. You
Or
can just
cycle. Can you share again? That.
just a second.
Okay, range of creep, stress structure, select the stresses, the magnitude.
So it will come out about 11.4 years.
Okay. So this is duration. It is not about cycles. Okay.
Yes, for 11 years, it should be okay. Yes.
So if after 11 hours they will assess, how they will assess? What kind of assessment they will do?
You have to do the material assessment. I have not experience on that.
Okay.
I think this remaining life assessment.
Yes. Atul have done assessment of used vessel, no? So it would be kind of similar on that.
Okay.
You might be able to explain regarding that.
Atul, did you done any remaining life assessment? Atul Sharma, you are on the mute.
No, for life, I only did it for anode calculation.
Okay, so vessel remaining life assessment you didn't done.
No, I did not do it.
Okay, we done some remaining life assessment. In that one, using I think API 573. There are some procedure they given in that one. Means first inspection need to be done that vessel completely, and the remaining thickness and that one they have to calculate, and after that one the how much the reduced means maybe the 13 years or 11 years whatever the range they used, initially what thickness they considered and now what is the thickness and how much it is reduced, and they will take that one, and accordingly they will decide further how many years it can run or you can not to be used this vessel, like that they will make the assessment in that one.
Okay.
So this I think now in PVElite also it's included remaining life assessment. So in latest version in that one. So you just
Yes, sir.
yeah.
Also, in PVElite, you can find the creep temperature range. It
Yeah,
will
yeah.
have an indication that the material is in creep range.
Yeah, yeah. Accordingly, that gives the values in that one. If it your vessel or your material is in creep range, and accordingly it will give the thickness or required that one. And life assessment, it's a different topic. It's because life assessment depends on the years of how many years it will run again this vessel.
Yes.
Okay. Anything, Ramakrishna? Any more?
I have one more question. This is regarding the PVElite. One of my client commented on it. See, we had the filter vessel. The condition was there was an internal pressure and internal temperature, and a steam out condition was provided, and a dry out condition. So the customer wanted to have all these conditions run in a simultaneous PVElite calculation. That is not possible, na?
We didn't get Ramakrishna. Did you got it?
See,
No, not possible.
yes, they had 3 pressure and 3 temperature.
Yeah.
They wanted to run it in a simultaneous calculation, and we said that we can take the worst one, but simultaneous calculation cannot be done.
Yeah, you can tell your client to join PVElite and help them to add this option.
But you can generate this different reports, and you can merge and you can submit like that. Also, you can do. No?
Yeah,
Yes, we can do that, but there wouldn't be any point. Now we have already provided them with the say 20 bar. We have done the calculation, and they want for the 5 bar also, but they want that added in the load cases.
that's not possible, na?
That's not possible. We can provide the separate file,
Yes.
but load case we can't change, na.
Yeah.
And
Yeah, but if they
I mean, maybe in future PVElite will do that. We don't know.
no, but if required, then PVElite will include. But I think if you are doing with 20 bar and they again the one more calculation with the 5 bar, then 20 bar is stringent. No, we can go with 20 bar. Why again require 5 bar?
Yeah, normally what happens, generally for the lower pressure, like steam out condition, temperature is high, and your distant temperature will be low. So in that case, it matters, but generally it happens.
Okay, you then means we might be what might consider the temperature means steam out condition your temperature more, so we consider higher temperature, and steam in temperature then your lower means pressure is high, then we consider higher pressure. That means both worst condition we considered and we designed that.
Yeah,
that is
but you are not sure whether you are doing the economical design or not.
Yes, but the thing was at both the temperature the allowable stress was same.
Okay, then no issue.
I don't thought they even also wanted to have the calculation as per ASME sectional division 1, but lifting lug they wanted as per PD.
Lifting lug as per PD.
Yes.
PD 55.
And rest of the calculation as per ASME. I mean,
No, only why lifting lug with PD 55 you are saying?
I don't know. It was
But for lifting lug there is no calculation in ASME as well.
yes, but if you select the ASME, they will just do the WRC calculation and the manual calculation of the moment, bending moment, and tension, shear and tension. So that's okay.
But that is not ASME. It is just general.
Not
general
a
one.
part of a code actually.
Yeah, it's general calculation. It's means it's referring some books and that one.
Good
Is,
engineering practice.
yeah, referring some books, Dennis Mouse and that one. It's done. It's not that.
Yes. But the concern is in PVElite, when you select the ASME section at division 1, that will be the only calculation that will come out.
Yeah, but that it doesn't mention any clause or any reference of these codes and that. This just gives the tension and these values.
I generally skip PVElite calculation. I don't use it.
But
because it is not correct.
No, even if you select PD 55 in PVElite, So is there any difference calculation comes for this lifting lug in your
The
calculation?
rest of the calculation will also come.
Yeah, but you can means in
No,
lifting lug,
no.
if you see.
What I'm saying, generally, I don't use PVElite calculation for lifting lug, tailing lug.
You just do the manual calculation.
Manual calculation, that is better.
Yes,
Always.
that is better, na? Because PVElite won't consider my cassettes and all that's requirement.
Yes.
No,
And
manual manual calculation what concern no clients means normally we worked in client side also. So their concern is that the Excel is small error also means you either you assigning F5 you assign F6 then complete value changes. So they are not sure that Excel calculations is that authentic. So they believe more on the software outputs. So they require that one. Yeah.
Software is also not correct, na? This especially tailing lag.
Tailing no calculation.
Tailing lag is if you select also it will give, but it is very very higher thickness will come. So that's why I don't trust PVElite for especially for lifting lugs and tailing lag calculation. I use my own.
Tailing like calculation doesn't come out, no?
No,
It comes.
it comes. In PVElite it comes. Telling like if you have to assign the CG and that one, it comes. It gives the values.
Comes, but it is not correct.
That we don't know because we just generated PVElite calculation and we submitted client. But client also happy with software calculations.
You don't do the calculation for the bracing beam also, no? See, often bracing beam requirement will be there. That check also it is not doing. I don't know, maybe doing, but I don't trust PVElite for that.
We can do manually also and we can verify with PVElite calculation which one gives better value. Or if you have more trust on ours, so just we'll add in this PVElite calculation with
Maybe I think PVElite should work more on this. I think they need to refine
Like
this.
calculation, no?
Yes.
Previously it doesn't have this lifting or tailing lug, but now they included all this. Even the transportation.
It is there.
In transportation calculation also they added now recently with.
Okay. Yeah.
So
After the meeting, can you share me the screenshot of the location where the thickness requirement of the tailing lugs is coming?
tailing lug thickness you want.
Yes, where in the code calculation they would be providing, because I ran the calculation and in my calculation when I search the tailing lug, the required thickness is.
No, that option is available in your skirt design.
Yes, I've added the skirt, I've added the tailing lug also. I have added the thickness and the hole size, everything. But after the running the calculation, the required thickness option dialog box is not.
Tailing lug required thickness you want, right?
Yes.
I think in
Maybe
tailing
I
lug,
am missing.
yeah, tailing lug it's takes few inputs only. Okay, I will share that one to you, maybe after this meeting.
Yeah, it takes only the width of the tiling lug and the location of your hole and thickness. That's it.
Yeah, but he didn't getting thickness value. I'm sure, right? You want thickness value.
Yes.
Okay. I
But
will.
for this tailing lug, at the during the lifting, there will be different angles, right? For that also the thickness has to be considered. Different angle, different moment will come.
Yeah, I think that calculation is doing. I think PVElite does that.
Because this calculation is not that easy, it's a complicated because it's a tailing lug. Because during the lifting, the vessel, vertical vessel or column will tilt at every degree, like 0 to 90 degrees. So every degree, at some degree, the moment will be high. So that's why it's not that easy.
Yeah, but this.
But PVElite is doing all that.
Okay.
That's actually PVElite. There is one option is there rigging analysis in PVElite.
Rigging analysis.
Yeah, in
Rigging
that
analysis for the lifting comes.
in that one every angle it checks and from 0 to 90 degree when it tilts, so all angle it takes care and it gives the values and which angle it gets more value, more stresses and that accordingly it gives the thickness required for
No,
the
that rigging analysis is to check your longitudinal stresses in your shell, not for the lifting lug or tailing lug design.
but it includes the tailing lug and lifting lug inputs in that
No,
one.
it will include in the tailing lug because normally we also, when I used to do the calculation, we didn't do in PVElite. We supposed to do in the Excel.
Yeah,
So that
before
was complicated. In the Excel, you have to put all the weight, and even the weight will come at different elevations. Automatically, the Excel will take. So then, in the tailing lug, that moment will change at every point.
yeah,
You have to
before
again change the input for the thicknesses. So I mean to
before
say the
we also
thickness
used to
is
do in the Excel only, but in I think 2019 it started in PVElite. They're giving the rigging analysis also in
I
their
think
software.
that was given.
No.
It is given.
It is since the beginning. I mean, it's not new.
Yeah, in Denison course it is given. It's like they describe how to do the calculations, all the degrees.
For
Yeah.
tailing lug, the calculation that you used to do.
Not is tailing lug, it's like combined. I mean to say the input is bottom and top. See, tailing
okay.
lug calculation is, I mean to say, if you consider only the tailing lug, then maybe it will come in safe. Okay, you put the weight divided by 2, so then it will come safe. The top and bottom, I mean to say. But when you put in the different degree, then this calculation, maybe you have to change even the bolt position. I mean, it's the whole position. The whole position also will change as per that. So
Yes.
that's why I mean to say Dennis most explained it. So it's you can just read it that one. You'll get some idea how to they do it.
For the moment arm of the tailing lug, lifting lug, or anything, how much distance you take from center to the basing top ring you consider, or from center to the attachment?
Center to
For moment arm, you consider the distance lug center. My voice
lug
is
center. Actually, see normally you put a hole right in the tailing lug to lift. Normally there is a one hole in the tailing lug, right? So that whole point will be your you consider the CG from that distance actually, because the load, it's not only the tailing lug, your ceiling also will come on that point. So that's why I mean to say the center point is your whole position. So before the hole and after the hole, there are some material. So that material, how much material you are giving, that's why the width also will change. If you do the calculation, the width also will change. You will change the height of the tailing lug also. Like that, it's like you have to do some manipulation on them. So that's why it is not like only the thickness. Lots of things to be considered on that.
Basically, section modulus.
Yes, correct. So, by the way, your lifting arrangement using the trunnion or it's normal lifting lug?
normal lifting lug.
Then I think you can do. It's normally. I mean to say you can take a higher thickness, because what my case I'm telling the column, which is very highly heavyweight. So then this consideration you have to take, because it's like cost wise. I'm telling you, it's a big column. You cannot just take the risk, and then you have to put the what you call the bracing also, bracing columns, bracing beams. So that is also in the same calculation it comes. Where to put the bracing beams? What is the section modulus of that bracing beam?
Yes.
So this long column you're talking about is shipped in multiple pieces, or it is single piece transportation?
No, single piece.
Single piece only. Okay.
Yeah.
What is the height? What is the length of the column?
There are multiple columns, so I'll say the height is almost 60 meters.
Oh, okay. I think 60 meter. I think it's not an issue. I think.
Sometimes the diameter is 6 meters.
Yeah.
So it's like really heavy.
Yeah.
Okay, so You got Anshul this rigging unless or tailing like okay. We'll share some of the whatever we have the inputs to you.
Yes, yes, no issue. Thank you.
Anything more?
No, not right now.
Okay. Kaushik, do you have anything to discuss?
No, not right now.
Okay. Ramakrishna, do you have?
Yeah, no, I don't. Thank you.
Okay. Can we close?
Yes. Yeah.
Yes.
Okay.
Thank you, everyone.
Thank you.
Thank
Thank you
you.
very
Yeah,
much.
thank you. Thank you, guys.
Bye.
Got it.